Hey Algebros, hopefully I haven't lost you yet. Hopefully you're sticking with these videos because 5 and 6 are just a slight difference. Not much though. All right, number 5, let's take a look at it. It says a library receives book donations over the course of the year. The number of books received each month is listed in the table. Write an expression to model the number of books received. So again, we're writing an expression. And I'm going the extra step in identifying what type, because when we know what type it is, it helps us write our expression easier, in my opinion. All right, so they already have a table, so I'm not going to fill in my x and y table, as we already have one. So that's my x values and my y values. So let's see, what can we do? From 2 to 11, we could add 9. From 11 to 26, you could add 15. From 26 to 47, you could add 21. And from 47 to 74, you could add 27. Okay. So that's obviously not consistent, but let's see if our second difference is consistent, since there's no way to multiply 2 to equal 11, so we don't have a ratio that we can see. 9 to 15 would be a plus 6. 15 to 21 would also be a plus 6, and 21 to 27 would also be a plus 6. So we have that second difference that's the same. So we know it's going to be quadratic. All right, so let's remind ourselves what quadratic is. Remember, it is ax squared plus bx plus c, and they're nice enough to make sure that we don't need to worry about that bx for this particular assignment and lesson. So we're just worried about that ax squared plus c. Now remember that x squared is always in our quadratic, so we can't change that. So we need to see what our a and c value is going to be, if we need an a and if we need a c. In all of our previous examples, we didn't really need an a value. A value was 1. But in 5 and 6, we will need a different a value. So we're going to see how we can figure that one out. So we have 1 squared plus something times something, 2 squared plus something times something, and we want this to equal 2, and we want that one to equal 11, so on and so forth. All right, so let's get creative. If 1 squared, if to get 1 squared, then add a value to that to get 2. You could add 1. Let's see if that works for the next one. 2 squared is 4 plus 1 would be 5, not 11. So that's not right. Remember, it's got to work for them all. So let's see, our second difference is kind of big there. Maybe we're going to multiply by something. So let's try to multiply by 2 out here. Let's start small. So if we take 1 squared, which is 1, times 2, which would be 2, plus 0 would be 2. So let's see if that works here. 2 squared is 4, times 2 would be 8, plus 0 is not 11, so that's not right. Let's see what else we can do. Let's try the next value. Let's try 3. 1 squared is 1, times 3 would be 3. To get to 2, we'd have to add a negative 1. So let's try it here. 2 squared is 4. 4 times 3 would be 12. 12 plus a negative 1 would be 11. Oh, we might be onto something. Let's see. So let's try 3 squared times 3 plus a negative 1. 3 squared is 9. 9 times 3 would be 27. 27 plus -1 would be 26. I think we have found it. So our expression would be 3x squared plus a -1, or 3x squared minus 1. Both are acceptable. So we kind of have to get creative. I have to think outside the box, see what works. Let's take a look at number 6. A website begins its first week with 3 subscribers. The number of subscribers each week is listed in the table. Write an expression to model the number of subscribers. So let's see what we're doing. So from 3 to 9 we add 6. From 9 to 19 we would add 10. 19 to 33 we would add 14. And from 33 to 51 we would add 18. So let's see if our second difference is consistent, and it is. So that means it's quadratic. So now we have to see what our A and our C value is going to need to be. All right, so if we start with just an A value of 1, we have 1 squared plus, we would have to add 2 to equal 3. So let's see if the next value would work. 2 squared plus 2, with 4 plus 2, okay, that doesn't work. Let's try adding an A value. So let's try 2. So 1 squared times 2 would be 2, plus 1 would be 3. So let's try that again. 2 squared is 4, times 2 is 8, plus 1 would be 9. So that works so far. Let's see, oops, that would be 3. 3 squared is 9, 9, 18, 18 plus 1 would be 19. All right, I think we found our pattern. Our A value would be 2, and we would add 1. So our expression would be 2x squared plus 1. Now, notice that our A value is half of our second difference in number 5, and our A value is half of our second difference in number 6. So that would always be a good place to start, is to look at that second difference and try half of that and see if that works. So that might be a little bit more straightforward method to do, but I just wanted you to see it, and you can trial and error just like I did, and you will eventually get to the right answer. All right, happy mathing today.